class, section 1.3 talks about quadratic equations. So friendly reminder that quadratic equations can be written in the form ax squared plus bx plus c, and we want to set those equal to 0. These are degree 2 equations, and this is the standard form of a quadratic equation. The graphs of quadratic equations form parabolas. So parabolas can have either two solutions, right? If they're vertex, that's where they have this line of symmetry, is below the x-axis. They can have one solution if their vertex is directly on the x-axis, and they can have no solutions, at least no real solutions, as long as their vertex starts above the x-axis. And we can solve quadratic functions by factoring and then using the zero factor property. So if a and b are real numbers with a, b equal to 0, then either a equals 0, b equals 0, or both have to equal 0. So what I need to do is substitute these back in. Nope. What I need to do is set each of these equal to 0 and solve. So here I'd have x plus 6 equals 0, or 2x minus 3 equals 0. I'm going to go ahead and subtract 6 from both sides. I get x equals 6. I'm going to go ahead and add 3 to both sides. I get 2x equals 3. Got both sides by 2. I get x equals 3 halves. So these are the roots. This is where our graph crosses the x-axis. We can write the solution set as such. So in order to solve a quadratic equation by factoring, the first thing we need to do is write it in standard form, factor our polynomial, use the zero factor property, and then find the solutions. You want to check your answers in the original polynomial just to make sure they are really solutions. So we're going to start doing that on this slide. So let's look at number 1. I have 2x squared plus 3x equals 2. But I need to make this in standard form, so I'm going to subtract 2 from both sides. Now I'm going to solve this by factoring. I want to know what are the factors of AC, which is negative 4, right? Because here's A, B, C, that add up to B, which is 3. And the factors of AC that add up to B are going to be 4 times negative 1. So I've got 2x squared plus 4x minus x minus 2 equals 0. And I'm going to go ahead and pull this apart and factor by grouping. The greatest common factor in my first binomial is 2x, so I have 2x plus 2. The greatest common factor here is negative 1. Remember, we don't like negative leading coefficients. So I'm going to have negative 1 times x plus 2 equals 0. I'm going to have 2x minus 1, because I collect my greatest common factors, times x plus 2 equals 0. I'm going to set each of my binomial terms equal to 0 and solve for x. So I have x equals 1/2 and x equals negative 2. We're going to substitute those into our original equation in order to check our solutions. So first let's check negative 2. If I have 2 times negative 2 squared plus 3 times negative 2, does that equal 2? Well, negative 2 squared is 4 times 2 is 8. 8 plus a negative 6 equals 2. 2 equals 2. I believe that's true. Next we're going to check 1/2. That gives me 2 times 1/2 squared plus 3 times 1/2 equals 2. So 1/2 squared would be 1/4. 2 times 1/4 is 1/2. Plus 3 times 1/2 would be 3 halves equals 2. 4 over 2, 2 equals 2. So both of these are my solutions to this parabola. Let's go ahead and work on example number 2. So here I have 4x squared minus 20x equals 0. I'm going to go ahead and pull out a factor of x. I have x times, so I need to pull out the greatest common factor because I have two terms here. What's the greatest common factor of 4x squared and 20x? Well, of course they have an x in common, but they also have a factor of 4 in common, so I can pull that out as well. That gives me 4x times x minus 5 equals 0. And I go ahead and set each of these terms equal to 0. I get x is 0 and x is positive 5. I'm going to go ahead and substitute this in to check my solutions. We can see that if x is 0, we are going to get a true statement. So let's look at x equals 5. 4 times 5 squared minus 20 times 5 equals 0. That's going to give me 4 times 25, so 100 minus 100 equals 0. This is a true statement. So our two solutions are x equals 0 and x equals 5. All right, let's take a look at example 3. I'm going to go ahead and clear us some space. So I have 3x squared minus 108 equals 0. So the first thing I want to do to simplify is I need to pull out the greatest common factor, where 3 is the greatest common factor. So I have 3x squared minus 36. That means I'm going to have 3 times x plus 6 times x minus 6, right? Because this is the difference of perfect squares. If you need to review factoring, feel free to go back and watch those chapter R videos. I think it was section 5 that covered factoring. So now I can set each of these terms equal to 0. I have x plus 6 equals 0 and x minus 6 equals 0. So I have x equals 6 and x equals positive 6. Sorry, negative 6 and positive 6, because I'd subtract 6 from both sides, and I would add 6 to both sides. When we substitute those into our equation, we're going to see that both of these are indeed our solutions. Last but not least, let's take a look at number 4. I have 2x squared plus 5x minus 7. So I want to know what are the factors of AC, which is negative 14, that add up to b, which is positive 5. Well, that's going to be 7 times negative 2. So I can pull apart that middle term so that we can factor by grouping. I'm going to go ahead and pull out the greatest common factor over here, which is going to be just an x. The greatest common factor of negative 2x and negative 7, that's going to be negative 1. Remember, we don't like negative leading coefficients. I'm going to collect my greatest common factors. So I have x minus 1 times 2x plus 7 equals 0. And then I'm going to go ahead and set each of these binomials equal to 0 in order to solve. I'm going to get x equals 1 and x equals negative 7 halves. And I leave it up to you to check the answers for this one. So if I want to solve a quadratic equation by graphing, what I'm going to do is I'm going to go ahead and graph 2x squared minus x minus 3. And then I'm going to use the 0 function. That 0 function helps us find the x-intercepts, and that's going to give us our solution set. Remember, the x-intercepts are also sometimes called the roots of the polynomial. So if u is an algebraic expression and d is a positive real number, then u squared equals d has exactly two solutions. U equals the square root of d, and u equals the negative square root of d. Why is this? This can also be written as u equals plus or minus the square root of d. And remember, this is because negative 5 squared is 25, and positive 5 squared is 25, right? We have our primary roots and our negative roots. So if I have x squared equals 9, and I want to set this equal to 0 and solve, right? I'm going to see there's two possible solutions. So I have x squared minus 9 equals 0. That gives me x plus 3 times x minus 3 equals 0. And you'd see I'm going to set each of these equal to 0. And you'll see I'll get the solutions x equals negative 3 and positive 3. But I could have done this a little more quickly by taking the square root of both sides. So I'd have x equals plus or minus 3.